Good evening, everyone. Can you all hear me? Please respond. Am I audible to all of you? If yes, please respond, all of you. Am I audible to everyone? Please respond. All right. So let's start here. So in the last two sessions of the Vedic maths, we have talked about how to find. Yes, hi, Vaumik. So in the last two sessions, we have talked about how to find the squares and the cube. So today we'll discuss, first of all, I'll talk about how to multiply. Okay, we'll talk about the multiplication technique. Okay, few important multiplication technique and also how to find the square root. Okay, square root and the cube root of perfect squares and perfect cube here. Okay, we'll discuss all the shortcuts about how to find the square root and cube root. Let's talk about the multiplication technique here. The thing which you need here as far as the multiplication technique is concerned, that is the base method. Now, what is that base method? Let's start here. For example, if I'm working on a base of 100, if the numbers are near to 100, okay, let's say I need to multiply numbers like 103 into 107, and I need to multiply these two numbers. So here I'm working on a base of 100. So you need to find out these numbers are how much greater or less than 100. Like here, 103. Can I say there is a surplus of 3? So I'll write down plus 3. 107. There is a surplus of 7. So write down plus 7. So that is plus 3 and plus 7. Your answer is in two parts. The last part is the product of these two. That is 3 into 7. And 3 into 7 is 21. So you can write down simply 21. And remember one thing, that the last part, it must be a two-digit number. That is very, very important. It must be a two-digit number. And the first part is either you add 103 plus 7 or 107 plus 3. Both of them will give you the same value. So 103 plus 7, it is nothing but that is 110. So my answer is nothing but 11021 here. Let's take a couple of more examples. Like if I say I need to multiply numbers like 112. Okay, 112 into, I can say 109, for example. All right. So I can say 112, there is a surplus of 12. So plus 12. 109, it means there is a surplus of plus 9. So write down plus 9. And then 12 into 9. So 12 into 9 is nothing but that is 108. Okay, 12 into 9 is nothing but 108. But remember, this last part should be always a two-digit number here. It should be always a two-digit number. Now you can add 112 plus 9, which is 121, or 109 plus 12. Both of them will always give you the same value. So 112 plus 9, that is equal to 121. And this third digit, it will get added here. So the answer is 1308. Now this is the case where both the numbers are what? Greater than 100. Now, where do we need all these things? Now, when solving question based on the percentages or maybe data interpretation, if I say in a certain year, okay, the value is X, it increased by 12%. All right. Then again, after another year, after a gap of another year, it increased by 9%. So what is the final value? Let's say if there is a question on a certain year, the value increased by 12% first and then 9%. And what is the final value? So it is actually what 12% increase means, that is 1.12x. Okay. And then 9% increase means I can say 1.09 into 1.12x, which means I need to multiply these two here. And such type of calculations are very common in data interpretation as well as especially the question based on the percentages here. So 1.09 into 1.12. So I can use all these techniques here directly and I can say it is nothing but that is equal to 1.308 here. Okay. So I can say that is equal to 1.308 or this is 120. Okay. This is not 1308. It was 12208. I was wrong. So this is 1.2208 here. So this is just one of the application here. All right. So this is the logic which is very, very important while solving the question based on DI. Now here I have taken a case when both the numbers are slightly greater than 100. Let's take a case where the numbers can be less than 100 also. If both the numbers are less than 100. For example, if I say the number is 98 and I need to multiply it by 93. Okay. So 100 minus 2, there is a deficit of 2. 93, 100 minus 7. So minus 2 and minus 7. Now take a product of these two numbers, that is minus 2 into minus 7. What is minus 2 into minus 7? That is equal to plus 14. Okay, plus 14. Now add alternate number. 98 minus 7. 98 minus 7 is nothing but that is 91. So the answer is nothing but it is 9114. Okay. For example, if I need to multiply 88, okay, into, let's say, I can say 88 into 94, for example. So 88 means minus 12, 94 means minus 6. And then minus 12 into minus 6, minus 12 into minus 6 is 72. And you can do like this one, 88 minus 6. What is 88 minus 6? That is 82. So the answer is 8272. Okay, 2. And the question is, where will I be needing all these things? Kahan zarurat padegi? I say there is in a certain year, something is that is X. Then there is a decrease of 12%. Okay, and then there is a further decrease of 6%. And what is the final value? So I can say this is X into 12% decrease means 0.88 and 6% decrease means nothing but that is 0.94. So I can say straight away this value is equal to 0.8272 times of X. So these are the applications here. So remember, there are three different possibilities. One of the case when both the numbers are greater than 100. Second case, if both the numbers are less than 100. And then the third possibility is if one number is greater and the another one is lesser. Any doubts to anyone as far as these two cases are concerned? If there is any doubts, you can write in the chat. Now let's take a third case. When one of the number is greater and the another number is lesser. For example, let's say I need to multiply 104 into 93. Okay, 104 into 93. Now 104 into 93, this is nothing but that is plus 4. And then there is equal to minus 7. Plus 4 and then minus 7. Now multiply these two. 4 into minus 7, remember it is minus 28, not positive. Very, very important. It is minus 28. And add these two. 93 plus 4, that is 97. If the last part is negative, then what to do? In that case, you need to take a borrow of from the previous term. Take a borrow of 1. Okay, borrow of 1. If I take a borrow of 1, it will become 100 minus 28. You just need to take its complement. So 100 minus 28. What is 100 minus 28? Kya hota hai? 100 minus 28 is nothing but that is 72. And this 97, since I have taken a borrow of 1, so this will become 96. So my answer is nothing but 9672. So whenever there is a negative, if one of the number is greater, one of the number is smaller, you need to take a borrow. Let's take another example. If I say, let's say this is 112 into 91. I need to multiply these two. Okay. I can say this is plus 12 and then this is equal to minus 9. So plus 12 and minus 9, 12 into minus 9. So 12 into minus 9, it is nothing but minus 108, right now. Okay. And 112 minus 9 or 91 plus 12, both of them will give you the same value. So 112 minus 9, that is equal to 103. Now remember, last part must be a 2-digit number. So if you take a borrow here, if you are going to take a borrow of 1, what will happen here? If I take a borrow of 1, then it will be 100 minus 108 and 100 minus 108 is still negative, isn't it? 100 minus 108, abhi bhi negative yoga. So you need to take a borrow of 2 here. Okay, so if you take a borrow of 2, then 200 minus 108 and 200 minus 108 is 92. And since I have taken a borrow of 2, so this 103, it will become 101. So the answer is 10192. All right. Okay. And so on. All right. So I hope that these two examples are enough to explain the concept that if there is an increase and there is other decrease here. So why do we need a numbers? Why do we work on a base of 100? Because in the question based on the percentages, or maybe in the DI, most of the time there is a growth of 12%, then I can say 5%, something like this one. So it is very, very closer to 100. So that's why we need all of them. So here maybe I can say in a certain year, the X, it increased by 12%, then further it decreased by 9%. So what is the final value? So I can say this is X into 1.12 into 9% decrease means 0.91. And this is equal to 1.0192x. Okay, because the product of 112 into 91 is 10192. So these are few applications, and I'm sure that when you are solving the question based on the DI, you can use all these concepts here. Now, similarly, we can also work on a base of 200, 300, 400, 500, anything. How? Let's see here. Let's say the numbers are closer to 200. I need to multiply 203 into 200 and let's say 7. So 203 plus 3, 207 plus 7. Take a product of these two. So 3 into 7 is 21. And then 203 plus 7, that is 210 into 2. Since we are working on a base of 200, so you need to multiply your first part by 2. Okay. So 2 into 210, that is equal to 420. So 42021. This will be the answer here. So if you are working on a base of 300, all right, if you are working on a base of 300, multiply the first part by 3. If you are working on a base of 400, multiply the first part by 4 and so on. Okay. Like, for example, if I say I need to work on a base of 300, or maybe I'll take the number like 193 into 212. I need to multiply these two numbers. So 193, work on base of 200 because both the numbers are closer to 200. दोनों 200 के पास में है. So 193 is nothing but 200 minus 7. 212 is nothing but 200 plus 12. So 12 into minus 7, 12 into minus 7, that is minus 84. And remember, if you are working on a base of 100, 200, 300, 400, the last part, the second part must be a 2-digit number here. All right. Now, after that, what do I need? You can say 212 minus 7. That is equal to 205. And the same thing, take a borrow. The moment I take a borrow, it will become 100 minus 84. And 100 minus 84 is positive, so that is fine. I need to take a borrow of 1 only, not 2 or 3. So if I take a borrow of 1, then 100 minus 84, which is 16. And the first part will be nothing but that is 204. So the answer in this case is 204. Oh, sorry. 204. I have written it wrong here. 205 into 2. The first part will be 205 into 2. That is equal to 410. I forget to multiply it by 2 and minus 84. Now take a borrow of 1. After the multiplying, borrow of 1. So this will become 40916, and this is the answer. Okay. So, and so on. So similarly, you can work on a base of 300, base of 400, and so on. So I hope that this method is pretty much clear to all of you, isn't it? Bhaumik, is that clear? The rest of you, all those who are present here. Okay. Now there are some special case of multiplication also that are not very, very useful, but good to know. What are those things here? Let's see here. If I say there is a number in the form of A5, or I'll say that is AX into AY, I need to multiply these two, where X plus Y is equal to 10. It means the sum of the last digit is 10 and the leading digits are equal. Like if I need to multiply something like 23 into 27. All right. All right. I'll go back. Just wait. Now, whenever it comes out to be negative, Okay, whenever it comes out to be negative, you need to very careful here. All right. So when I say 205, like this is minus 84, last part can't be negative. So it means you need to take a borrow from the previous term. So if you take a borrow of 1, एक borrow लोगे तो ये क्या हो जाएगा 100 minus 84 और 100 minus 84 क्या होता है 16 here. So I can write down 40916. Okay, let's take another example. Okay, whenever there is a negative, then how to do it? For example, if I say, let's say I need to multiply by something, okay, at random I am taking 113, okay, and let's say 96, for example. This is plus 13 and this is minus 4. So I can say 13 into 4 is minus 52. Okay, 113 minus 4, that is 109. So again, I need to take a borrow here. So if you take a borrow of 1, it will be 100 minus 52. And 100 minus 52 is 48. And this 109, since I have already taken a borrow of 1, so it will become 108. So the answer is nothing but 10848, like this. So I hope that now it is clear. Now, in case if it is a 3-digit or 4-digit, something like if I say, let me take some larger number, 115, okay, into 88. So this is plus 15, 88 is minus 12. So what is 15 into 12? So I can say 15 into minus 12, that will be equal to minus 15 into 10 is 150, and that is 180, minus 180. Okay. And then 115 minus 12. 115 minus 12 is equal to 103. Now, second part is negative, so we need to make it positive. So I'll take a borrow from the previous term. If you take a borrow of 1, it will be 100 minus 180, which is still negative. Remember, 100 minus 180, अभी भी क्या minus 80, negative है, छोड़ दो. So take a borrow of 2. अगर 2 का borrow ले रहे हैं तो ये 200 में से subtract होगा. So 200 minus 180, that is equal to 20. Okay, 200 minus 180 is equal to 20. And this 103, since I have taken a borrow of 2, so it will become 101. So the answer is 10120. Now I hope that it is clear. Is that clear now, Mohammed? All right. So yes, let's come back to this. If I need to multiply, a very special case of multiplication technique here. If I'm multiplying something like ax into ay, where the sum of the last digit, it is 10 and the first digit is same. Something like 23 into 27. Or maybe I can say that means 34 into 36. Or maybe I can say that is 41 into 49. Or maybe I can say, let's say 72 into 78. Or maybe 112 into 108. Something like that here. Okay. So in that case, you can observe here, if you are observe, okay, 3 plus 7, it is 10. 4 plus 6, 10. 1 plus 9, 10. 2 plus 8, 10. And 2 plus 8, 10. Whereas the leading digit is same. Leading digit, the first digit is sabka same hai. So how to do? Your answer is in two parts. The second part is always a 2-digit number. Okay, second part is always a 2-digit number. So I'll say 7 into 3, 21. Write down. Like in the second case, 4 into 6, 24. In the third example, 1 into 9 is 9. So I'll write down 09. 72 into 78, I'll write down 8 into 2, 16. And 112 into 118, 8 2s are 16 here. Okay. And what is the first part? First part is nothing, but that is always the number into number plus 1. Like here, in the example of 23 and 27, this is 2. So you need to multiply 2 by 3, the next natural number. After 2, 3 comes here. So 2 into 3. 2 into 3 is nothing but 6. So this is basically 2 into 3. Now in 34 into 36, it is 3. So multiply 3 by 4. Okay, 3 by 4. 3 into 4 is 12. So that is the first part. Now 41 into 49. 4 5s are 20. So this is 4 into 5. 72 into 78. So this is 7. After 7, we'll get 8. So 7 into 8 is nothing but that is 56. So you can write down 56. And similarly, 11 into 12. 11 into 12 is nothing but that is 132. 132 here. Okay. So now it is equal to, I can say 621. This is 1224, 2009, 5616 and 13216. So in general, if I say this is AX into AY. So last part is X into Y. And the first part is A into A plus 1. But this last part, it must be a 2-digit number. So this is a very special case of, I can say some special kind of the multiplication, a unique case here. So if you are able to observe this pattern in some questions while doing the multiplication, you can apply it here. Is it clear to all of you? I hope that it is clear. Now, then there are a few other techniques also. Multiplication, something known as the crisscross method. I'm sure that most of you have heard about this crisscross method. But frankly speaking, I didn't find this method to be very useful in the exam or in the questions here. It is okay to know for a crisscross method for 2-digit number, but for 3-digit number, it becomes complicated. 4-digit, it will become further complicated. So I'm going to tell you for the 2-digit number. Okay, and if you think that, okay, but for that also, you need to practice a lot. If you practice, then only you can increase your error. Something like if I say I need to multiply 23 into 47. Okay. So your answer is in 3 parts. Remember, middle part, it must be a single-digit number. And the last part should be also a single-digit number. That is very, very important. So what does this crisscross method says here? Let's try to understand. Multiply these two, like 3 into 7, 21. Write down 21. Okay. Now, 2 into 7 plus 3 into 4 plus, remember, 2 into 7 plus 3 into 4. So 2 into 7 is 14, 3 into 4 is 12. So 14 plus 12. 14 plus 12 is 26. So write down in the middle 26. And the first part is the product of these two. 4 into 2, 8. So what is the step? I'll say this, then this, and then this. Okay. But since middle part has to be a single-digit number and everything, so this 2, it will become your carryover here. So this is 1, then 28, and then 8. Then this 2, it will get added here. So 8 plus 2 is 10 and 1081. So this is the final answer. Now here I have written step by step just to explain it to you. But this entire calculations, it can be written in one line. Once you practice, you can write down in the entire thing in one line. So this is the step which you need to remember for multiplying two-digit number. Okay, if you need to multiply two-digit number here. Okay, that is very, very important here. Let's say, for example, if I need to multiply, now I'll do it in a one single line, this calculations. If I need to multiply something like, okay, let me take any number at random, 37 into 62. So I'll do it orally now. 7 2s are 14, 4 carryover of 1. Then I'll say 3 into 2, 6 and 7 into 6, 42. Okay, cross. I'll say 3 into 2, 6 and 7 into 6, 42. So 6 plus 42 is equal to nothing but that is 48. And the carryover of 1, 49. So write down 9 in the middle and now the carryover is 4. Now multiply these two. 3 into 6 is 18 and 18 plus 4 is 22. So my answer is 2294. So what we are doing actually, instead of multiplying by single and writing the numbers in 2 layers and adding, what I am doing? I am doing all the calculations in my mind and writing them in one line. Okay. So this is known as the crisscross method. So maybe for 2-digit. Now similar approach is also there for 3-digit number. But let me tell you one thing, even if I'm going to tell you the crisscross method for a 2-3-digit number, There is hardly any use of that. Okay. Because for 3-digit number, your answer will be in 5 steps, like this or this, and then this and this and this. Or if you serve on the Google, if you try to search 3-digit number crisscross method here. Okay, why is the nomenclature Vedic maths? That's a very interesting thing. Vedic maths, it is basically, it has been based on one slogan, that is Navam Nasat Dasam Dasat. If you read, there is a slogan in the Sanskrit, Navam Nasat Dasam Dasat, which means all from 9 but last from 10. The meaning of that slogan is all from 9 but last from 10. And that is, in most of the things, it is based on that particular concept here. So that's why it has been known Vedic maths. There is no reading. Okay. It's all about that because maybe our ancient, बहुत जो पुराने जमाने में लोगों ने इंडियन कल्चर में ही ये सारा डिराइव हुआ था. So that's why it is known as Vedic maths. Very ancient period of time. All right. Okay. So there are various techniques, but I'll discuss only those things which we can use in our calculations techniques or maybe in the quant session. Okay. Now let's talk about something about how to find the, I hope that now it is clear, the multiplication. Now there are few special case also, like multiplication by 11, multiplication by 9, 99, 999. We'll see. If there is a time, I'll discuss that also. But let's come to the important thing here, square root techniques. Square root of perfect squares. Now remember, I'm just going to tell you for perfect squares. Now how to find the square root of any other number? Okay, that I'll discuss in the calculation technique. Okay, how to do the approximations and everything. That is the part of approximation techniques here. But how we can calculate the square root of a perfect squares? Because I have observed in a lot of occasions, quant में कुछ ऐसे questions होते हैं where I need to find out the square root, and mostly it is a perfect square because in the options also, they are not in terms of decimal fractions. So it means I need to find out the square root. So how we can calculate here? Okay. Now you need to remember one thing which is very important here. Let's take any number. I'll just take here. I need to find out the square root of 6241. Okay. I need to find the square root of 6241. So focus on the last digit, that is 1. Take the square root of the last number, which is equal to 1. Okay. Take the square root of that number 1. Take its complement. Okay, complement means 10 minus 1. And that's the Vedic maths, that Navam Nasat Dasam Dasat. All from 9 but last from 10. Complement में क्या होता है? सारे नंबर को 9 से subtract करते हैं except last जिसको 10 से subtract करते हैं. So if I need to take a complement of 1, 10 minus 1 is 9. Write down 9. Now neglect the second last digit completely. You can neglect this. Okay, 4. Now look for 62. 62, ये किसके बीच में lie करता है? It lies in the square of which number? Now I know 8 square is 64, isn't it? And 7 square is 49. So here the term 62, it lies between 7 square and 8 square, isn't it? So 7 square is 49, 8 square is 64. It means my answer is in 70s. Okay. It is between 70 to 80 because 80 square it will be 6400 and 70 square will be 4900. So my answer must be between 70 and 80. So I'll write down here 7. So your answer is either 71 or 79 and there is no other possibilities. यही दो आंसर हो सकते हैं, इसके अलावा और कुछ भी नहीं हो सकता है. Okay. So the answer is either 71 or 79. Now how to identify whether the correct answer is 71 or it is 79? ठीक है, कैसे करेंगे? So for that you just need to check here. There are two approaches. One of the approach is simply 62. Is it closer to 7 square or 8 square? 7 square 49, 8 square is 64. तो ये जो 62 वो 64 के आसपास है या 49 के आसपास? Of course closer to 64 because the gap between 64 and 62 is 2. And the gap between 49 and 62 is very high. So since this number is closer to larger number, so my answer is nothing but that is 79. It should be a larger number. So there are two ways, like I'm telling you. This is the first way. 62 is closer to larger number. So among these two options, take the larger number. Or the other way is simply multiply 7 into 8, 56. 7 to 8 into 8 is 56. And since 62 is greater than 56, so take the larger one. That's it. Okay. Let me take another example. I'll take lots of examples. For example, if I say I need to calculate the square root of 8281. Okay. So again, last digit is 1. So take the square root of 1. Square root of 1 is 1. Okay, square root of 1 is 1. And its complement, that is equal to 9. Neglect 8. Now we are left out with 82. So 82 is between which number? We know 9 square, it is 81. 10 square is 100. Okay, so my answer is in 90s. So answer is either 91 or 99. And then there is no other possibilities here. But then again, you need to check whether 82 is closer to 9 square or 10 square. 9 square 81, 10 square 100. So of course 82 is closer to 81. So 82 is closer to 9 square, the smaller number. So my answer is also the smaller among these two, which is 91. Okay. So since 81 is closer to this, 82 is closer to a smaller number, so your answer is a smaller number. Or what you could have done is simply take 9 into 10, 90. And since 82 is less than 90, so take a smaller number. All right. So my answer is 91. So I hope that it is clear. In case if there is doubt, feel free to ask. You can write down in the chat. Okay. Let's take a couple of more examples. Like I need to calculate the square root of 6889. Try it on your own. I'm sure that you all can find out the answer. Okay. 9. So square root of 9 is 3. Okay. Square root of 9 is 3 and its complement is 7. So write down 3 or 7. That's it. Neglect the second last digit. Now 68. 68 is in which range? We know 8 square is 64, 9 square is 81. So 68 is close, okay, between 8 and 9. So answer is either 83 or 87 and there is no other possibilities. या तो 83 होगा या 87 होगा. अब check 68 वो 8 square 64 के closer है या 9 square 81. So of course 68 is closer to 64, the smaller one. So my answer is 83. So I can say square root of 6889 is nothing but that is equal to 83. So I hope that it is clear. If not, raise a doubt. Okay. Now, for example, let's say I need to calculate the square root of 6724. Okay, 6724. Last digit is 4. So take the square root of 4, which is 2. And take its complement, that is 10 minus 2, which is 8. Okay. Neglect this. Now 67. 67 is between 8 square and 9 square, isn't it? So 8 square is 64, 9 square 81. So my answer is either 82 or 88. And there is no other possibilities. यही दो में से एक होगा. Now, tell me 67 is closer to what? I think 67 is closer to 8 square, isn't it? 64K. So answer is 82. So this is equal to 82. All right, this is equal to 82. That's it. Let's take another example. Square root of 4356. Now 6. Now, if like I told you, always take a square root of the last digit, but square root of 6 does not exist. In case the square root does not exist, write down the number as it is, 6. And then take its complement 4. So जब भी कोई number हो जिसका square root exist नहीं करता last digit का, take the number as it is always. Like root of 6, write down 6 and 6 complement 4. Neglect now 5. 43. So I think we know that 7 square is 49 and 6 square is equal to 36. Okay, so answer is either 66 or 64, and then there is no other possibilities. Okay, either 66 or 64. Now I need to think which is there. Now 43 is closer to 36 or 49. So I think the 43 is closer to 49, isn't it? Or in case there is a doubt, multiply 6 into 7, 42. So 6 into 7 is 42 and I am getting 43. So it means it is greater than that. Okay, it is greater than this one. So I need to take a larger number. So among 66 or 64, the larger one is 66. So its square root is 66. That's it. So I hope that now it is clear. And the only thing which you all need to do is you just need to practice. That's it. So any doubts in this technique now, please respond, guys. If there is no doubt, then I can move to the how to find the cube root of a perfect cube. Now you can even use this technique for 5-digit, 6-digit also. All right. So let's move ahead. Let's move to the how to find the cube root of a perfect cube. Okay. How to find the cube root of a perfect cube here. Now, you should remember the cubes of first 10 natural numbers. If you know the cube of the first 10 natural number, you can easily find out the cube root of all the natural numbers starting from 1 to 100. And that is more than sufficient. Okay. Let's see how. So what is the cube of the first 10 natural number? I'll say 1 cube, it is equal to 1. 2 cube, which is equal to 8. 3 cube is nothing but that is 27. 4 cube, it is nothing but 64. 5 cube, it is equal to 125. 6 cube, it is equal to 216. 7 cube, it is equal to 343. 8 cube, which is equal to 512. 9 cube, it is 729. And 10 cube, which is equal to 1000. Okay. So these are the cubes here, like 1 cube, 2 cube, 3 cube, 4 cube, and so on till 10 cube here. Now, let's see. Very interesting fact, the cube of 2, it ends with the 8. And the cube of 8, it ends with the 2. Okay, just see here. Cube of a number ending with the digit 2, it ends with 8. And the cube of a number ending with 8, it ends with the 2. So 2 and 8, remember, they are correlated. And 2 plus 8 is also 10. Same thing here, the cube of 3, it ends with 7. And the cube of 7 ends with 3. So these are things which are important. So cube of 3 will always end with 7 and the cube of 7 ends with 3. That's it. And for the rest of the case, the last digit is same. Like 1 cube ends with 1. 4 cube, you can see it here, ends with 4. 5 cube ends with 5 only. 6 cube ends with 6. 9 cube ends with 9 and 10 cube ends with 0 only. So only in case of cube of 2 will end with 8 and cube of 8 will end with 2. Cube of 3 will end with 7. Cube of 7 will end with 3 and so on. So let's see how I can use all these facts to find the cube root here. Now let's say I need to find out the cube root of a perfect cube, which is, let's say, 29791. Okay. Now this is 1. So it cube roots also ends with the 1. Abhi bataya कि only in case of 2 will end with 8, 8 will end with 2, 3 will end with 7, 7 will end with 3. That's it. Write down 1. And then neglects the next two numbers, 7, 9. Now we are left out with 29. And now just say 29 lies in which range? 29 is between 3 cube and 4 cube, not 27 or 64 के बीच में. So ये 27 और 64 के बीच में है, between 3 and 4. So my answer is in 30s and 40. It is between 30 and 40. So I'll simply write down 3 and this is the answer. Remember, in case of cube root, you will get a unique answer. There will be no two possibilities. You'll never get two possibilities. There will be always a unique value. So 29, 27 और 64 के बीच में, तो I'll take 3. That's it. So 40 क्यूब से कम होगा और 30 क्यूब से ज्यादा होगा. So answer is 31. Now let's say I need to find out the cube root of a number like I'll say 74088. Now if it is 8, take its complement, that is 2. I told you, like for 2837 you need to be careful. Okay, so replace 8 by 2, neglect the next two number. Now we are left out with 74. Check 74. 74 is between 64 and 125. It is between 4 cube and 5 cube. So if it is between 4 cube and 5 cube, my answer is nothing but between 40 and 50. So answer is 42. That's it. Okay. Let's say I need to find out the cube root of 148877. Okay, 148877. Now, how to do that here? Same logic, 7. So replace by 3. Neglect the next two number. Now 148. 148 is between 5 cube and 6 cube. You can see here. 5 cube is 125, 6 cube is 216. So 148 is between 5 cube and 6 cube. So my answer is 53. Okay, the answer in this case is nothing but that is 53. All right. Let's say if I need to find out the cube root of something like, if I say 658503. 3. Okay, so it will end with 7. Neglect next two. Now 658. 658 is between 8 cube and 9 cube. You can see here. 8 cube is 512, 9 cube is 729. So it is between 8 and 9. So answer is 87. And that's it. Okay, so this is how we can find out the cube root of a perfect cube. So I hope that this method is clear, how to find the. Now, where do we need, especially in a question based on the compound interest? Sometimes we get a formula like this one, 1 plus r by 100 raised to power 3 principal equal to amount, and 1 plus r by 100 raised to power 3, it is equal to amount by principal. And maybe I need to find out the cube root, or maybe if it is power 2, I need to find out the square root, and most of the time it is a perfect square or perfect cube. So you can then use all these techniques to find that here. All right, so let's stop here. It's 7:45 and we'll meet again at 8 o'clock. 8 बजे फिर से मिलते हैं, and I'll start with another very interesting session of time, speed and distance. All right. In case if there is any doubt, please ask me right now. Okay, so good night to all of you. And those who are joining, we'll meet after another 15 minutes at 8 o'clock for time, speed, distance session. If there is any doubts, I'm still here. You can ask me any question. I'm still here for another 1 or 2 minutes. So please ask me if there is any doubt to anyone. Okay, guys. So I'm going to log out now. And agar session अच्छा लगा, so please like the session and share it with all of your friends and everyone. Okay. Okay, cube वाला एक बार फिर से. Let's take another example. Like I need to find out the cube root of 941192. So if it is ending with 2, write down 8. Neglect the next two number, 19. Now 941. So I know that 9 cube it is equal to 729 and 10 cube it is equal to 1000. So 941 it is between these two. So I'll write down 98. So the answer is 98. Okay, the answer is nothing but that is 98. Okay. Like if I say I need to find out the cube root of 438976. Only 2, 3, 7, 8 will interchange. Rest of the things will remain same. So this is 6. So write down 6 as it is. Neglect the next two number, 97. Now 438. So 438. I know 5 cube, 6 cube, 7 cube. Okay. And 8 cube. I know that the 8 cube it is equal to, or 7 cube it is equal to 343. And 8 cube it is equal to 512. So 438 is between these two. So 438 is between these two. So answer is 76. And that is the answer. So is that clear now? Rishikesh, Bhaumik. So if there is a doubt, please ask me. I'm still here. All right. Usually in the chat, there is a lag of 10 to 20 seconds. So I'm still here. You guys can respond. Okay, guys. So chalo. See you at after another 10 minutes.